Hello everyone, my name is Sania Mirajkar. Welcome to Clarity Hub, your one stop destination for clear, simple, and effective learning. So, today we will learn flame photometry. Flame photometry is an important technique used in chemistry to detect metal ions in a sample. So, we will look at how it works, its construction, principle, introduction, its working, advantages, disadvantages, and its real life application. Next, introduction. Flame photometry is also called as flame atomic emission spectroscopy is an analytical technique used to determine the concentration of certain metal ions in a sample. Next, principle. The principle behind flame photometry is based on emission of light by atoms or ions. When they are heated with the help of flame, in the flame, metal ion absorb energy which promote them to an excited state as those excited ions return to their ground state. They emit light at a specific wavelength. The intensity of this emitted light is proportional to the concentration of metal ions in the sample. To ensure the accurate measurement, proper sample preparation is crucial in the flame photometry. Okay, so flame photometry is a technique for determining the concentration of specific metal ions, mainly alkali and alkaline earth metals like sodium, potassium, calcium, and lithium. When a sample containing metal ion is introduced in a flame, the heat excites the atom, causing them to emit light. Each element emits light at a characteristic wavelength, and the intensity of light is directly proportional to the concentration of metal ions in a sample. Next, we will see here the diagram. This is the diagram or construction of flame photometry. We can see one by one. So, construction, sample introduction. In this nebulizer converts the liquid sample into flame aerosol mist. Then mixing chamber mix the aerosol with fuel like propane or natural gas and oxidant as usually air. Spray chamber remove large droplet, allow only few mist in the flame. So nebulizer turns the liquid into mist. And then flame burner. A controlled flame burns the simple mist. The heat excites the metal ions and they emit light at a characteristic wavelength. So flame heats the excite heat and excite the atoms. The next, optical system. Optical system consists of slide, lenses, and filter or monochromator. As you can see here in this, okay, let it be. Focus is on a select or specific wavelength of a light emitted by excited ions. Help isolate signal for specific element. The next, monochromator select the light wavelength. And the next, detector as usually a photocell or photomultiplier tube. It convert light intensity into electrical signals. Like detector measure the light intensity and then convert into electrical signals. The next, readout system. From the name you can understand its working. The electrical signal is amplified and show on the digital display or analog meter. Some devices are connected to data logger or computer for detailed analysis. So readout device show the results. You can see here, this is the construction here. The photo detector is here, the flame and the lens, amplifier and readout device, etc. We will see the working. Next. So working, flame source. Propane or acetylene or natural gas is used to generate the flame. Sample introduction. The sample solution is nebulized spray into nebulized means sprayed into a fine mist using a nebulizer. The next, flame atomization. The mist is then introduced into a flame with the help of atomizer in a controlled manner. The flame atomizes the sample, providing the necessary energy to excite the metal ions. Then, excitation and emission. The excited ions emit the light as they return to their lower energy state. Each metal ion emits light at a characteristic wavelength. The next, detection. The emitted light passes through a filter or monochromator which permit only the radiation characteristic of an element under the investigation to pass the photodetectors. A photodetector measures the intensity of emitted light. The output from its measure is digital output system. So in short we can say flame is produced, then sample is nebulized into fine mist, and then mist enter the flame where the ion get excited, and after that excited ions emit light and filter selects the desired wavelength. Detector measure the intensity and at last readout give the result. So this is the working of flame photometry, and then next we will see advantages of flame photometry. So the advantage of flame photometry is simple. It is simple and cost effective. The equipment is affordable and easy to maintain.